So today is looking at mixed resistor circuits, circuits that are going to have some parallel, some series resistor components. What's our strategy? First thing, you've got to recognize which parts are in parallel, which parts are in series. If necessary, we'll simplify the total circuit to find the total equivalent resistance, R total, because then we can go like this. We can use total current equals total voltage over total resistance. You may right now at the top of your page want to write V equals I times R and power equals V times I, because also, as always, anywhere in a circuit, Joss, if I know two things, I know four things. Or if they give me two pieces of information, I can find whatever else I need to solve the rest of the circuit. So after we know total current, we want to, total resistance, we want to find total current. By the way, total voltage is usually going to be the voltage from the battery or cell. And then apply Kirchhoff's rules. We're going to ski. Example 1. Identify resistors in series or in parallel. Let's decide we're going to circle resistors that are in parallel, and let's decide we're going to put a square box, put a square box around resistors in series. There's our high-tech S for square, C for parallel. I don't know. Which resistors are in parallel? The top left, the middle, or the right? Okay, so these two are in parallel. If I wanted to, I could combine them. I could combine them by going 1 over this resistor plus 1 over this resistor. In fact, you know what? Let's put some numbers on here. Let's make this one here 5 ohms. Let's make this one here 10 ohms. And let's make this one here 10 ohms. If I wanted to rewrite this circuit, the first thing I could find is R parallel. Well, no, I can find 1 over R parallel. My abbreviation for R parallel is R and 2 parallel lines, just like I did way back when for ramps parallel to lines. It's going to be 1 over 10 plus 1 over 10. That's what we learned last day. I'm cautious. I don't put an equal sign right here because technically this doesn't equal that. It equals the reciprocal, and I'm going to take the reciprocal. So I always draw an arrow. I won't take marks off if you put an equal sign there, but I'll frown because it's not an equality. Anyways, on our calculators, what do? Oh, we go 1 over 10 plus 1 over 10 reciprocal. 1 divided by 10 plus 1 divided by 10 reciprocal. We all have our calculators out. 1 divided by 10 plus 1 divided by 10. And then I showed you the reciprocal button, x to the negative 1, and I get, oh, that's the same as the 5 ohm resistor. So if I redrew this, what I really have is the battery. I have the original 5 ohm resistor that they gave me, but this parallel component can be replaced with 5 ohms. Yes? So here's the real question. What's the total resistance of this circuit? What can you tell me about these two resistors, series or parallel? So how do I find the total resistance when everything is in series? Yeah, 5 and 5 is? Okay, this circuit that I just made up has a total resistance of 10 ohms. By an amazing fluke, it worked out evenly. Usually they don't when I make these up. And now that I knew total resistance, if you told me total current, total voltage, I could find total current and I could walk my way through this whole thing. These three are in series. I could combine those as one by adding them up. Once I did that, I would now have this combined resistor and this combined resistor in parallel. And I could go 1 over this thing plus whatever this thing added to, 1 over that. Once I had that, I could add it to that and get total resistance. You know what? We really need to jump in and get to the numbers. Let me pause the video. I got a latecomer. What about here? Hey, these are parallel. Those are parallel. And so if I wanted to, Tori, I could rewrite this as a single resistor, a single resistor, and a single resistor, and now those are all in series, add them up, and I'm good to go, and I can find whatever I need to. I'm seeing a few glazed eyes. Let's jump into some actual numbers. Oh, we'll skip that. Let's go to example 2. Example 2 says this. Find all voltages and currents, and then if necessary, draw a summary diagram. So, first thing I'm going to always try and do is see, have they told me current or total current anywhere? So this is my strategy. If they had, I'd start there and I'd see if I could follow the current breaking up and rejoining, breaking up and I'd ski with the current. Have they told me total current anywhere? No? Okay. Then the next thing I would do is see is any resistor with 2 things. Because if they've given me 2 things, James, I know 4 things specifically. If they give me 2, I can probably find a current or a voltage, and those all help. Did they give me any resistor with 2 pieces of information anywhere in this diagram, James? Do I know 2 things there? Do I know 2 things there? Do I know 2 things there? No. Okay. My final resort is to rewrite the circuit. Okay. Which resistors are in parallel? 10 and 15. So I'm going to go like this. And if you're wondering, Max, how much work I look for on a test, I would look for this part jotted down somewhere. I would give you 1 mark if I saw 1 over R parallel equals 1 over 10 plus 1 over 15, and then an arrow pointing R parallel equals what? 1 divided by 10 plus 1 divided by 15. And you want to practice this along with me just so you get good and quick at this and so that you get in the habit of, once you hit equals, hitting that reciprocal button, because that's by far the most common mistake. By the way, 6 ohms, yes? And I think I told you the built-in error check. Duncan, how big? How big? I knew the answer was going to be less than 10. So if I got something bigger than 10, I'd messed up. So R parallel is 6 ohms. So now I'm going to do a real quick sketch. I guess what I now have is a 20-volt battery. And then as I move here, Robbie, can you see it's a 4-ohm resistor along the top? And then those 2 parallel ones can be combined into 6 ohms. And this is a sketch. I'm not being fussy with my proper circuit notation or anything, but I don't care about that. I want it to be stupidly obvious. Brendan, what's the total resistance in my new sketch? That's what and I want it to really stare in my face. Add them up. So you're telling me our total is 10 ohms. I would look for that written somewhere. I would give you 1 mark if I saw that. Why is that so important? Because now I can find I total. It's going to be V total over R total. Brendan, what's the total voltage going through this circuit? What's the total resistance? In your head, please. 2 amps. I went to 2 sig figs. This is rough work, so I wouldn't be fussy on that unless it asked you that as your final answer, but it's just a habit. So now I'm going to go back to my original circuit. I probably should have labeled which way was downhill. That's downhill, that's downhill, that's downhill. How many amps, folks, do I have leaving the battery? 2 amps. So let's follow. James, how many amps do I have going through this first resistor then? How many amps do I have going through this? How many amps do I have leaving the battery? What did we just say? What's the total current? Ready? What's the total current? Amps. Ready? So how many amps leaving right there? How many amps right there? How many amps in here? And I pause because now I know two things. I know four things. I can tell you how many volts I lose through there. V equals I times R, Sam, in your head. V equals I times R, Sam, in your head. V equals, I know, I'm picking my audience. You were zoned. You're back now. V equals I times R, in your head, please. I times R, in your head, please. 2 times 4 is? 2 times 4 is? Loud and proud? Okay. How many volts do I lose going through this resistor, Sam? Ready, Sam? We're going back. I know you were away last day. That's why I'm picking on you. How many volts did we start with on the battery?
20.
How many did I just lose here?
8.
Leaving how much?
12.
So now I'm going to ski. I notice I can go this way, and that gets me to the bottom. I must have lost a total of 20 volts going through that path. Well, if I lost 8 and I'm left with 12, how many volts must I lose going through this resistor? I have to lose 12 volts. Do I know 2 things on this resistor now, James? I know 3 things. I can now find the current. The current is going to be V over R. 12 divided by 10. Sam, in your head, 12 divided by 10. Oh, thank you for coming back to the land of the living. James, how many amps did we just say here? How many amps were coming in? So if 1.2 amps went this way, how many amps must have gone that way? James, do I now know 2 things? Then I know 4 things. I can find everything I want. I, 0.8, times R, 15. Really, you're going to use a calculator? Okay, I'll live with you using a calculator. Go ahead. I'm pretty sure the answer is going to be 12 volts. Can I tell you why without doing that? I skied instead. I said, you know what? That path also gets me to the ground. And you just told me I lost 8 right there, leaving how much? And if I go through here, I better lose those 12 volts going through there as well. So I have often you're going to find by the time you get to the last few resistors, you got, Robbie, several ways you can go. It said find all voltages and currents, done. Now, this would be a test level question, although I would probably say find the power flowing through the right-hand resistor. How many watts of power is going through here? How can I calculate that? Yeah, 12 times 0.8, 7.2 watts. No, I'm off. 9.4 watts, 9.6 watts. Wow. Sorry, I got a case of the Sams. Okay. Uh-oh. You good? This is going to be our strategy. Again, I find these, sadly, you know what? I find these addictive, like Sudoku puzzles or what. I really get into solving circuits. So, example 3. Basically, it's the same one we just did, except on the right-hand side, instead of one big resistor, I've broken it up into 3 smaller ones. But wait a minute. What can you tell me about these 3 resistors here? The 12, the 6, and the 2. They are in, I'm looking for a word that begins with the letter S. They're in series, which means really this is the same as how big a single resistor? 20? Let's just pretend in our minds that there is a 20 there. I could redraw this. I'm lazy. But I think I can say 1 over R parallel is going to be 1 over 5 plus 1 over, help me out, 20. What's R parallel the same as? Really? It works out evenly again? That's how you know I didn't make these questions up. 4 ohms. Last time I redrew the circuit, but can you just pretend in your minds that this whole thing now looks just like this, except there's a 4 ohms sitting right there? Can you imagine that, Andy? Is that okay? So here's my question. What's the total resistance of this circuit? 6, and this whole mess is 4, and they are mathematically in series in our imagined mathematical equivalent. Rebecca, you agree with me? I think Duncan is right. Our total is 10 ohms. Yeah.
All of those add up to 20.
All of those add up to what?
Well, the 3 on the right add up to 20.
Yeah.
But if you're doing all of them, that's
But these are in parallel, so these 3 I can add up because they're in series, but they're in parallel with this, so I'd have to go 1 over 5 plus 1 over 20.
oh,
Right? By the way, I'm glad you made that mistake. That's a very common one. And maybe I'm going a little fast. I'm skipping drawing a lot of stuff on purpose here to see how good we can get. Is that okay? So this whole mess works out to 4, and then there's a 6 in series with this mathematical 4. We get a 10, and now it's going to start to repeat itself. I total is V total over R total. Sinead, what's the total voltage? Go look at the battery. Okay. Now, if you don't have the battery, and once in a while you won't, you can still probably figure out the total voltage, Sinead, by doing a whole ski run and just adding up along the way. They'll give you enough that you can figure out all those. So a good question is they give you extra information and they say, hey, how big is the battery? So, but, okay, we can do it still. 30, what was the total resistance, Sinead? Oh, you know what? This circuit has 3 amps. Coming back to James now. James, how many amps does this circuit have grand total? So what's leaving right here? You know what? Let's label downhill, 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 downhill. Good. So how many amps are flowing through this first resistor, folks? 3 amps. Pause. I know 2 things. I now know 3 things. Sam, how many volts do I lose going through that first resistor? Thank you. You're back now? Okay. Leaving how many volts? And it seems to me one way to ski would be through that way. Yes? That gets us to the bottom. And the reason I picked that one is it's a simpler one than this other one that has all these. How many volts must I lose going through this single solitary resistor here then? Got to be 12 volts. Now I know 2 things. I know 3 things. How many amps are going through that middle resistor? 12 divided by 5? 2.4? James, how many amps did we have grand total? If 2.4 went this way, folks, how many went this way? In fact, I think it's 0.6 amps, 0.6 amps, 0.6 amps. And now in each of those resistors, I know 2 things, so I can find everything else. Not only that, these 3 resistors' voltages better add up to 12 volts, because if you can split up and meet up, these people went down one big hill. These skiers went down one big hill, 12 volts. These skiers went down 3 smaller hills, but since they're splitting up and meeting up, they better have lost the same voltage. Here's my 7.2 volts, yes. Here's 3.6 volts, yes. And here is 1.2 volts, yes. And I'll bet you if you add those up, 7.2 plus 3.6 plus 1.2, they do add to 12. Okay. All I can do is practice this some more, but really this is the whole lesson. And this is how circuits come together. Now, in real life, Nick, we're being a bit sloppy. In real life, wires actually have some small resistance of their own. We're ignoring that. And as a circuit runs, its temperature changes, and so the resistance actually does change. We're ignoring that. So we are back in my magic physics world. But if any of you go into electronics or whatever, this is they might teach you a more formal mathematical method, but this is what you'll be doing to analyze and make sure your circuits work. Yeah. Quick look, money. Oh, and then all you'll do is you'll learn more circuit components, capacitors and diodes, and the rules for those, Brendan, how they fit into a circuit. Nice questions are questions that ask you about total current or brightness of bulbs when you open or close a switch. So this says, what happens to the total current in this circuit as measured by the ammeter when the switch S is closed? No change, increases, decreases. Yeah. Let's find out. Draw a little line like that. Let's actually solve this circuit while it's open, and then we'll solve this circuit while it's closed. And by solving it, we'll find while it's open, R total. Now, while it's open, since this is open, no current will flow. You can just imagine that that wire doesn't exist. Don't do that on your diagram, but we can just imagine that, which means I have a 20 and I have a 5, and that 20 and that 5, how are they wired together, series or parallel? So what's my total resistance? What's my total current? Well, that's going to be V total divided by R total. It's going to be divided by 25. I get 4 amps. Are you beginning to see why Duncan and Brendan have to be wrong? There has to be a change, because I'm pretty sure when I close that switch, the resistance is going to change, which means the current has to change. The total resistance is going to change because the equation is going to be different. Real question is bigger or smaller. Okay? So one neat thing about adding resistors in parallel, let me say this again. One neat thing about adding resistors in parallel, when you add a resistor in parallel, even though you're adding a resistor, because it's in parallel, you always lower your total resistance. The total resistance is good. This number is going to get smaller. The current is actually going to go up. But let's prove it. So first, when I close this switch, now I've got a 5 and a 10 in parallel. I'm going to have to go 1 over R parallel is 1 over 5 plus 1 over 10. The parallel component is .3 reciprocal, 3.333 repeating. So the total resistance is what if I close the switch? 23.3 repeating, because now they're in series with each other. So the total current is going to be 100 volts divided by 23.3 repeating. I think I said total resistance goes down when you add a resistor in parallel. I think we've just shown that. I think I said that means that total current goes up when you add a resistor in parallel. When you add a resistor in parallel, here's what happens. First of all, it's like opening an extra ski hill. If you open an extra ski hill, you can get more skiers on the mountain. Current's going to go up. You're going to drain your battery faster because you're using more current, which also makes sense because you've just added an extra light bulb or something. Of course you will drain. Of course current has to go up. You're going to drain things faster. I get 100 divided by 20 plus that. 4.3 amps. So what's the answer? A, B, or C? B, and there's my proof. If they didn't give you any numbers, if they did this purely algebraically, although you can try solving these algebraically, I just typically make up numbers and crunch the numbers because I'm pretty good at that. I'll put a voltage on the battery. I'll often use 48 volts because lots of stuff goes evenly into 48. And I'm lazy and want to be able to try and do stuff in my head. The only thing I'll avoid, I'll never make a 1 ohm resistor because when I'm doing resistors in parallel, 1 over 1 is 1 and I might get confused. So I'll go 2s, 5s, and 10s, 3s, that kind of thing. Avoid 7s and 19s and things like that if I can. You okay with that so far? Number 1. Number 2. Number 3. Number 4 is good. All 4 is asking you to do is just find the total resistance. I don't even care which way the current is flowing. 5 is drawn weird. Look where the battery is. It's in the middle, so I guess that's downhill. Downhill is that way. Downhill is that way. See if you can follow it, or if you want to, you can redraw it. I'll give you 5. 6 is good. 7 is good. 8 is good.